All right, so we're going to review the second page of the pretest together. That would be Form 2A. I hope that you have completed Form 1B on your own. This one you can follow along. Make sure you're showing all of your work because you will turn that in to schoolwork, and we can go over any additional questions that you have tomorrow. So number 1, it says use the circle shown for exercises 1 and 2. 1 says, what is the circumference of circle D? Round your answer to the nearest tenth. So in the picture, I have to determine whether it gives me the radius or the diameter. The segment it gives me goes from the center to the side, so it gives me the radius. I have both the formulas written down for you. Remember, I told you the formulas would be given. I'm going to choose the one that uses radius, 2 pi r. And now I'll go to my calculator. I'll type in 2 times pi times 5.5, and I'll round to the nearest tenth to get 34.6 meters. Number 2, I'm looking at the same circle. It says, what is the area of the circle? Round your answer to the nearest tenth. Area formula is written there, and I already have determined that they gave me the radius is 5.5. So I'll plug that in. Pi times the radius squared. Because of order of operations on my calculator, I will do 5.5 squared first, times pi, and I will round to the nearest tenth to get 75.0 meters squared. Number 3. The blades of a ceiling fan rotate about a circle of 226 inches. What is the most likely length of the ceiling fan blade? So if you can picture a ceiling fan, something like this, where each of these are the blades. So first I have to determine, is the blade a radius or a diameter? Well, the blade goes from the center of the fan to the outside, so it would be the radius. If the blades are rotating about a circle of 226 inches, that's my circumference. So I'm going to choose the circumference formula that uses radius. I'm going to plug in 226 where I see C. And now I'm going to solve for my variable. First, I'll divide both sides by 2. And then I'll divide both sides by pi to find that my radius is 36 inches. Number 4. Suppose a car tire has a diameter of 26. How many complete rotations will the tire make if it travels 1 mile? Well, first I notice that it gives me the diameter. If I'm talking about a full rotation, I'm talking about the circumference. So I'm going to choose the circumference formula that uses diameter. Second thing I notice is that the diameter is given in inches and it's asking about traveling a mile. Well, this is something that I would give to you on the test as well. 1 mile is 63,360 inches. So let's solve for our circumference first. Pi times 26 gives me a circumference of 81.68. Well, that would be in inches, and I want to know how many rotations it will make in a mile. So I'm going to take that 63,360 and divide it by one of my rotations. To find out how many rotations I'll go in that entire mile. And that is 775.7, which is about 776 rotations. Number 5. A circular hot tub located near the middle of a rectangular patio has a diameter of 60 inches. So I'm going to draw this out. I have a rectangular patio, and I have a circular hot tub in the middle. That hot tub has a diameter of 60 inches. The patio measures 9 feet by 12 feet. What is the area of the patio that is not covered by the hot tub. So first, I'll notice that I have inches and feet. So I'm going to change my 60 inches into feet by doing 60 divided by 12 inches in a foot. That would give me a diameter of 5 feet. My area is going to be the entire rectangular patio minus the part covered by the hot tub. I have 12 by 9 and I have 5, all in feet. I decided to change it to feet because if I look at all of my answers as options for number 5, they're all written in feet. So area of a rectangle is the base times the height, 9 times 12, minus the area of a circle is pi r squared. Well, the diameter is 5 in this, which means the radius is 2.5, or 5 divided by 2. And at this point, I'm plugging into my calculator. Start by doing 9 times 12, 2.5 squared because of order of operations, times pi. And now I'll subtract and round to the nearest tenth to get 88.4 feet squared. Number 6. 1/4 of the top of a round wedding cake is covered in pink roses. The top of the wedding cake has a diameter of 9. Each pink rose has an area of 1.25 square inches. How many roses were used to cover this section of cake? Well, it says it's round, and I'm only covering 1/4 of it in these roses. So the area that they would cover would be the area of a circle, but I'm only looking at 1/4 of it, 1/4 pi r squared. They tell me the diameter is 9, which means the radius would be 9 divided by 2, or 4.5. So I'm going to plug in my variable and solve for my area. 4.5 squared times pi. You can either do times 1/4 or divided by 4 to get 15.9. But they didn't ask me for the area covered. They want to know how many roses. Each rose is 1.25 square inches. So I'm going to take the 15.9, the entire area I'm covering it, and divide by one single rose. This gives me 12.7, or about 12 roses. Number 7. If I were to break up number 7, I see a square in the middle, and I see one full circle here, and another full circle here. Which area formula will not help you find the area of the composite figure? Well, if I needed to find the area, I see 2 circles and 1 square. Okay, so that would be 2 pi r squared and the base times the height. But you could also rewrite this as one of the sides squared, because side times side on a square would be side squared. You could also rewrite this as the length times the width. So which one are you not using? That would be option D. Option D is the formula for the area of a triangle. Number 8. What shape describes the cross-section that results from an angled slice of a cone? So remember, a cross-section, you're asking yourself, if I were to slice this open and look at it, what am I going to see? So if I were to cut through the cone right here, what shape will you see? Well, it's going to be this curved kind of half circle. We said this was called a parabola. Now, if I asked you a different direction, perhaps horizontally, it would be a circle. But pay attention to which way we're slicing. It said at an angle, not horizontally. Number 9. find the volume of each figure. Well, if I look at this shape, I see it's sort of a house. So I'm going to need the volume of the triangular prism on top. I know it's a triangular prism on top because it has two bases that are shaped as a triangle. And I'm going to need to add the rectangular prism on the bottom. I know it's a rectangular prism because the bases are rectangles. So let's start with the triangular prism. I need the area of the base times the height. Okay, well the base is a triangle, and the area formula for a triangle here would be 1/2 base times height. So I need 1/2 the base of the triangle, 7, times the height of the triangle, 3, times the height of the prism. Well, the height of the prism is the thing that goes from one base to another, and from one base to the other would be 10. One triangle to the other. Now, let's go to our rectangular prism. I also need area of the base times the height, but the area formula for a rectangle is the base of the rectangle times the height of the rectangle. I see 10 times 7, and the height is what connects the two bases, which would be 8. And at this point, I'm going to my calculator. 7 times 3 times 10 divided by 2, or times 1/2, same thing, 105. 10 times 7 times 8. Add them together. 665 feet cubed. Number 10 is also asking me for volume. Well, I will need the volume of the cone plus the volume of the cylinder. Volume of the cone is 1/3 pi r squared times h. It gives me the diameter of the circle is 10, which means the radius is 5. So on the cone, I have 1/3 pi times 5 squared, and the height on that cone is 6. The cylinder is the area of the base, or pi r squared, times h. So that would be pi times 5 squared times the height of the cylinder is 12. And now go to your calculator. Exponents first, 5 squared times 6 times pi divided by 3, or multiply by 1/3. Exponents first again, 5 squared times 12 times pi add them together, and round to the nearest whole number, 1,100 millimeters cubed. Number 11. If the dimensions of the cone are doubled, what happens to the volume? Well, if our volume formula for a cone is 1/3 pi r squared h, and I'm doubling, that means I'm multiplying by 2. Remember, whatever I do to one side, I have to do to the other. So I would start by doing r times 2, which means I would have to multiply by 2 on this side. Then I would do h times 2, which means I have to multiply by 2 on this side. So what happened to the volume? Well, 2 times 2 is 4 times v. Okay, but we didn't take into account that this 2 is going to be squared. So we made a little bit of a mistake here. Let's back up. Okay, so my radius is going to get multiplied by 2. That means I'm squaring both the 2 and the r. So I could write this out as 2 times 2 times r times r. Then I'm going to have to multiply the h by 2 as well. Okay, so What happened to this side? I multiplied it by 2 times 2 times 2. Remember, we have to do the same thing to the other side. 2 times 2 times 2. Whatever we do to one side, we have to do to the other. 2 times 2 is 4, times 2 is 8. So what happened to our volume? It was 8 times as great. So be careful with your exponents. Don't make the same mistake I did at first. Number 12. A packaging engineer needs to affix a label to cover each of 4 cylindrical containers. Which of these has the least surface area? So let's go through each one. Letter F says the diameter is 4, which means the radius is 2 and the height is 8. So my surface area would be 2 times pi times r times h plus 2 times pi times r squared. Okay, 2 times 2 is 4. 4 times 8 is 32 pi. 2 squared is 4 times 2 is 8 pi. Add your pi's together, you get 40 pi. Let's look at letter G. The diameter is 8, which means the radius is 4. And my height is 4. Surface area is 2 times pi times r times h plus 2 times pi times r squared. 4 times 4 is 16, times 2 is 32 pi. 4 times 4 is 16, times 2 is 32 pi. Add them together, I get 64 pi. Remember, we're looking for the least. So this one's already out because F is smaller than G. Letter H, my diameter is 2, so my radius is 1, and my height is 16. Surface area would be 2 times pi times r times h plus 2 times pi times r squared. 16 times 1 is 16, times 2 is 32. 1 squared is 1. 1 times 2 is 2. 34 pi's. Okay, now this one's out because 34 pi is now our smallest. Let's try the last one, letter J. Diameter is 16, which means the radius is 8 and the height is 2. Surface area is 2 times pi times r times h plus 2 times pi times r squared. 8 times 2 times 2 is 32 pi. 8 times 8 is 64, times 2 is 128. Add those together, and you get 160 pi. So our smallest one is letter H. You don't even have to deal with the decimals. You can keep the pi there. It kind of tags along like a variable, and you're adding your like terms. Number 13, identify the figure shown by name. So start there. It has 2 bases. So I know that it has to be a prism because it has 2 bases. Now ask yourself, what shape is the base? What is there only 2 of? Well, there's only 2 triangles, so therefore the base is a triangle. It is a triangular prism. Draw a top view of the figure and label each viewable edge and vertex on the diagram. So remember, this is like you're flying in an airplane and you're looking down at the bottom. You're not going to see that it's actually a 3D figure. What are you going to see? You're just going to see the rectangle. And we can label this. I'm going to be able to see A, F, C, and D, and that BE is going to look flat. So that would be my top view. Number 14 is broken into 2 parts. Letter A. A model of an Egyptian pyramid has a slant height of 5 1/4. which I can rewrite as 5.25. And a 3-inch square base. Square base means all the sides are the same, so each of them is 3. Find the surface area of the pyramid. So surface area, I need 1/2 the perimeter times the slant height plus the area of the base. I have the slant height. The perimeter is the distance all the way around the square. So I could add up 3 plus 3 plus 3 plus 3, or I can do 4 sides that are each 3 to get 12. To find the area for a square, I would do base times height, or length times width, or side squared, which would just be 3 times 3, or 9. Now plug in 1/2 perimeter times the slant height plus the area of the base. 12 times 5.25 times 1/2, or divided by 2, and add 9 to get 40.5 inches squared. It's talking about area, so I need to make sure that I label it correctly. 14b. How many times as great is the surface area if the dimensions are doubled? So let's do something similar like we did in number 11. So I'm doubling these dimensions. And you can even actually double them if you want to. You can say the perimeter, well, if each side was 3, now each side will be double, or 6. So the perimeter would be 4 times 6, or 24. The slant height will have to be double, so 2 times 5.25, that would be double the slant height that they gave me. Okay, and then the area of the base, instead of 3 times 3, it would be 6 times 6. So this would become 1/2 times 24 times 10.5 plus 36. Okay, so how do I go from 162 to 40.5? Well, if I do 40.5 times 2, it's 81. 40.5 times 4 is 162. So this is 4 times as great. The second question says, is it the same for volume? Well, we already actually answered that question in number 11. A volume, if you double each of them, is going to be 8 times as great. So since we already answered that in number 11, we are done with 14. So again, you should have finished 1B on your own.